Hi, this is a tutorial on how to use the JLCPCB assembly libraries in EasyEDA, how to export these components into Altium or Circuit Studio so you can use them in those development tools instead of EasyEDA, and then I'll go through on how to basically make your own exported libraries, integrate them into Altium and Circuit Studio, and then be able to do your designs, circuit design, PCB layout, etc. And then I'll talk about how to export your Gerbers, everything, and then your pick and place files through Altium or Circuit Studio, and how to actually get that through to the JLCPCB website, and then be able to actually use their pick and place service without having to use the EasyEDA development tool. So the first step is to basically go into EasyEDA, because the thing with JLBPCB is when you go onto their, or JLCPCB I should say, when you go onto their website, they do not actually give out these libraries for free. This is to encourage using the EasyEDA development tool, but it does come with limitations, especially when you're trying to do polygon pours, and the layout and variant checking and all that. It's not a fully polished professional tool like Altium is. So what you do is basically to basically export these footprints. What you're going to do is you're going to go say find what you wanted to use. So let's go NE 555 or something like that. And say we wanted to use this chip, and we can see that there's enough in stock for the pick and place service. So you always want to check that. Price looks good. Replace this component. Then I'm going to say, well, I need a couple of 1K resistors. We'll go into here and, just for instance, I'll place one there and say 100 nanofarad capacitor or something in our circuit. And I'm just going to do these three components just to make things easy, and just get to the gist on how to export and get it all working in Altium and Circuit Studio. So here's our three components. So first thing I'm going to do is we're going to make the schematic library in Altium and or Circuit Studio. It's basically the same deal. So I'm going to go export. Well, we'll go save. I'm going to go export Altium. Oh, one sec. Okay, so now I fixed that. I just logged in. I had to quickly make an account. So I've got these three components, and they're all in stock. And we're just going to assume this is our basic, circuit. Well, these are the basic components we'll export. So first you go export. You go Altium, and you'll download them. So going into a downloads folder, I've downloaded this sheet, which is through the EasyEDA website. I'm going to open it up through Circuit Studio. So now I've opened it up in Circuit Studio. In Altium, it's exactly the same process. This tutorial basically works for Altium and Circuit Studio. Circuit Studio is really just the cheaper version of Altium with a few limited features, but their library construction, schematic library, PCB library construction is all the same, and you can follow the same steps that I'm doing here in order to basically make an Altium library. So we'll just make a new library, and then we'll add to that library a schematic library. Now what you do is you go to the imported sheet. You're just going to go copy, right click on the component in the sheet, copy. You're going to go down to schematic library, components description, list, inventory thing you want to call it. Delete that default one. So what this does is it imports it straight into here. And if we go to component properties, you can see that it's kept basically all the parameters that are important when we're going to export these pick and place files later for use through the JLBPCB website. One important thing to note is that I grabbed this from the extended range from the JLBPCB website. But if we go back to EasyEDA, the big difference here, say when I looked at this 100 nanofarad capacitor, we go to JLBPCB, you just you typically, what, like if this is a true realistic situation, I typically choose, look into that part number, see if it's got the right voltage rating, etc. Right? Um, resonance, whatever. But you basically, if you choose from the SMT type basic range, you're basically not getting charged. I think by memory, it's about $3 per real change. So if you want to save a couple of bucks, it's definitely worth not grabbing the extended range. But that's fine for this tutorial. So yeah, we're just going to repeat this process for the next couple of components. So what I'm going to do now is now I've imported all the components to the library. What I'm going to do now is I'm going to basically save this library. I'll just save it to the desktop. lib. And now we need to basically get the footprints for these, and it's pretty much a very similar process. Basically, what we're going to do is we're going to go to back into our schematic sheet. We're going to go save. We're going to go design, update PCB. No, don't worry about the nets because we're not actually exporting a proper design here. Just the components we're interested in. Set those all to default, and this seems fine. So we can just basically click out of that. Again, doesn't matter about the board outline. So we're going to save this. I'm going to go export Altium. So at this point, basically you have an Altium PCB dock. So there are some version changes with Altium and sorry, differences. So basically this schematic can be opened in Altium or Circuit Studio without any issue on compatibility. But the PCB docs will need to be opened in Altium and saved as their binary file for Circuit Studio to interpret it correctly. So basically, now I've opened up, it's an older version of Altium Designer, but basically, I've opened it up and I basically, again, drag the PCB in there. Altium Designer correctly interprets it, but you notice there are a few kinks with the overlay and stuff, but with the interpretation. So, but in general, it doesn't mess up the footprints too much. And I've had quite a bit of success with this. Although sometimes it does mess up the rotation, so it's something to double check when you go in. So now we want to go just save as, and we just want to save it as a PCB 5.0 binary file. Again, if you're basically making the PCB library in Altium, you can basically stop here and basically just do what we did again, just go copy, click right in the corner there, and basically just put it straight into your Altium library. But I'm going to just show you how to do it across the board for Circuit Studio as well. Basically, these both steps will cover both, so it works out alright. So I'm just adding the PCB library here. Save that, we'll just call it test. And now what we're going to do is we're going to go File, Import. And we'll go Downloads. And now we've basically imported that Altium PCB file. And we're just going to go copy. Go to our PCB library components. Paste them in. Delete this one for tidiness sake. Alright, so now we've basically got dragged in our three components here, and our three PCB footprints. We can go back to the schematic, we can go tools, component properties, and we can verify that the footprint is actually linking between the two. We can save our library and import it, and that's basically what I've done here. So view libraries, I've imported test lib.schematic. We've got our components that we can pick and place wherever we want them now, and basically I made this dummy circuit which is nonsensical, makes no sense, and I've imported it and routed it on a 10 by 10 centimeter PCB layout panel. And now what we can do is we can basically just export or generate our outputs, Gerbers, a pick and place file and stuff, all for the JLCPCB website. So we go generate outputs. Bill of materials is probably the trickiest one to get right. So if we go configure, what you want to do is you want to use a custom template. I'll link a download in the description below, where you can make your own. Essentially, this template is just going to have the following configuration, where we go column equals component, column equals description, column equals designator, column equals footprint, column equals libref, quantity, BOM manufacturer part, BOM manufacturer, BOM supplier part, and then BOM LCSC assembly. So what I've done is I've imported that path to the Excel sheet as my template, and now we've basically can see that all the parameters can be ticked on the left hand side, and they've shown up. So we've got component, description, designator, footprint, libref, and if you basically don't want a part to be basically laid out or added to the pick and place, this last column here is quite important, which you can just say yes or no if it's if you want it to be placed as a piece pick and place part. So that basically is your bill of materials. Gerber files pretty straightforward. With JLCPCB, they're a 4x4 format, and referencing relative to the absolute origin works out alright. NC drill files, although we actually don't have any tool holes or, in this PCB, but most PCBs will have one. Again, 4x4 reference to absolute origin. Generate pick and place part file is a CSV format with metric. So what we can do now is I can go generate outputs and then just hit generate. This may take a bit of time, I'll just fast forward. So now that the outputs are generated, I've gone to the outputs file, and what we can do is we can go to the JLCPCB website and order our pick and place board. So I'm just going to go quote now. I'm going to take the Gerber, I'm going to take the NC drill files, I'm going to go zip them up. Just rename it to I'm going to drag that onto here. It will automatically detect the dimensions of the board and the layers, etc. But it's worth checking that they get them right. It looks about right. We're a 2-layer board. Probably detected 1 layer because we've got no actually holes or bottom side tracks. But we need to declare it as a 2-layer in order to be meet the specifications for the thing. So we're going to assemble top side. We want a quantity of 5 tooling holes, add by JLCPCB, although you can add your own, but for this tutorial we're not going to go that far. So now you've asked to upload your BOM and your pick and place file. So I'm just going to go BOM. And it's worth just opening this up so you can double check that template worked properly. And as you can see, it has, and we can see okay. That's our template itself. So we can add that BOM file there. We can go to pick and place and add our pick and place file. These pick and place files are basically the same output that Altium gives you as well, which is quite good. Very simple, just is the component rotated, positional information, designator information, etc. So now I've hit that, we can hit next. And we see that our 3 parts have shown up. Basically, if it says confirmed, it means it's found it in the design and it's in stock. So you can see our parts are 10 cents here, tenth of a cent here, tenth of a cent here. It's quite good. Then we can hit next, and this is quite a crucial part, is you need to zoom in. You need to double check the rotation of your components is correct, especially if you've got a polarized capacitor, ICs, etc. And I can see that the dots line up there, and you can see all our parts have been generated and they look about right. Our parts list come up here. We've got a quantity of 5 each of our parts, and we can see basically what it adds up. So we've got an additional, basically adds up to about 23 Australian dollars for me to get 5 boards assembled, which is pretty good. Once you get into more complex designs, using basic parts and not using those extended reels should pay off. And now that I've done that, a board's ready to order. Go through its review process and get it ordered. And yeah, hopefully this tutorial has been helpful. I just made one because I didn't find anyone else showing how to get the JLCPCB or JLCPCB, sorry, assembly component schematics and PCB footprints, and make it compatible, so you can actually export designs from Altium and Circuit Studio, which are more common and robust design tools over EasyEDA, and use the JLCPCB assembly process, because it is quite cheap. And when you do go through EasyEDA and look at the components, they actually have quite a large range. It's decent range of extended components and ICs, etc. Cool. Hopefully that's been helpful. Yeah, thanks for watching.